Hello and welcome to our lesson today on adding integers on a number line. The first thing we're going to start out talking about today is expressions and equations, which we also refer to sometimes as number sentences. These vocabulary words can be found on your reference sheet in the very front of the packet if you're unsure of them, but these are very common things to use in math. You're going to notice that both of them have a set of numbers, and since we're working with the operation of addition, all of these will be adding. So first let's talk about the expressions. Expressions are made up or comprised of numbers, sometimes variables, which we'll talk about later, and an operation. But what's missing is an equal sign. And when we find the answer to an expression, we write the answer underneath. It's kind of like it funnels down. So 3 plus 7 would be 10. So you might have experienced where some teachers have you kind of write that as it funnels down, for instance, kind of like this, particularly when you're working with order of operations. So 21 plus 14 is also an expression, so we would write the answer underneath. Now when we move over and we look at the equations, these look similar. They have numbers and operations, but they have the ever important equal sign. So when you hear the word equation, I want you to know that that must have an equal sign. So 2 plus 6 would be 8, and we write the answer next to the equal sign in an equation. And 18 plus 12, well, that is 30, and again, we write it after the equal sign. So now let's move on to the next part. We are going to start with some very basic problems because our goal today is to learn how to model them using vectors. And if you watched the video yesterday on absolute value, the math antics teacher talked about vectors. And we're going to use the number line way. There are several strategies with which we can add integers. You're also going to notice that today we're going to focus on same sign numbers. So when we start, we always start at 0 on the number line. And to add a positive integer, we move an arrow to the right, the number of spaces represented by the number. And to add a negative, we draw an arrow to the left, the number of spaces represented by the number. And the last number where the vector landed on is the answer, and we circle it. So this is what this looks like. We're going to start at the number, or the number 0. That's what we're supposed to start with, even though I want to start at 2. So we're going to start right on the number line at 0. And we're going to count 1, 2. Now I'm just using this to count. Here's where the vector comes in. A vector is a line with an arrow that points in a certain direction. So now this is an example or a model of positive 2. And we move to the right because it was positive 2. Now we want to start right where we left off in order to do the second number. So we're going to start at 2, but we're trying to go 7 counts. So we're going to count 1, 2, 3, 4, 5, 6, 7. So I'm going to model the second vector until I end up where my number is. So this vector represents a positive 7 because it went to the right, and the directions say when we land on a number we should circle it. So of course we're working with basic numbers, and you probably already knew that the answer was going to be 9. If you noticed, I put it underneath this because this is an expression. I don't want to write it to the side. So let's try that again. Again, you could probably tell me what the answer to this problem is, but we're going to start our problem at 0. That's what the directions say we're supposed to do. So we're going to start right at 0, and this time I'm going to count 6. I'm moving to the right because it is positive 6. And the first number is admittedly the easiest because we start at 0 and we go to that number. So our first vector goes to the right, And I'm going to call this 6. That's a model of 6 using a vector. Now, this is always the tricky part. I don't go back to 0. Once I've started at 0, I stay where I'm at. Now, I'm going to model the number 4, but I start where I left off. So I'm going to go 1, 2, 3, 4. Remember, I left off at 6, I started at 6 and went 4. So my vector is going to look like the length that it took me to get to 10. So this is not a model of 10. This vector is a model of 4. So a length of 6, a length of 4, and you probably already know what the answer is. But because it's an equation, we put it after the equal sign. So now let's go to the next page. The next page is where we bring in our negatives. It's going to be the same process. The vectors are just going to go a different direction. So I'm going to start at 0, but this time because I have a negative 3, I have to go to the left. 1, 2, 3. And I was expecting to land on negative 3, and I did. My vector this time is a model of negative 3, and it's very important that I'm showing the direction with my vector. The next number, I can't go back to 0. I'm already at negative 3, so I'm going to start it at negative 3, and I'm going to count 1, 2, 3, 4. I went to the left 4 because it's a negative 4. So I'm going to start where I left off. I'm going to draw my vector. This is a representation of negative 4. And last time I forgot to circle my answer. So if you want to go back and do that, that's great. So we landed at negative 7. So that's our answer. Again, it's an expression. We write it underneath. All right, so let's try this last vector together, or this last addition on the number line together, not vector. And then I'm going to have you try 3 on your own. So we're going to always start at 0. We're going to go to the number line at 0, and I see the very first number I'm supposed to model is negative 1. So I'm going to count over negative 1. I went to the left because it's negative. So this is a model of negative 1. Now I'm going to start at that negative 1, and I'm going to model negative 5. So starting at 1, I'm going to count 1, 2, 3, 4, 5. I like to count on the number line so I'm very clear how long my vector is. And this is a model of negative 5. And you can probably see where we landed. We landed on negative 6. So my answer is negative 6, and it goes behind the equal sign because this is an equation, or what is also sometimes called a number sentence. So let's finish out our portion together by reading through some important facts. Was the sum or the answer to addition expressions or equations of 2 positive numbers, positive or negative? So you can look on the front, or you can think about it. What would happen if you add 2 positive numbers? Well, you would get a positive answer. So let's circle that. We would get a positive answer. Next, it asks what was the sum, was the sum, which is an answer. A sum means an answer to an addition expression or equation of 2 negative numbers, positive or negative. Well, if I look at this, I just got done doing it. We just got done working on this together, and we added 2 negatives, and we got a negative answer, and that happened to the one above. So it turns out that every time we add 2 negative numbers, we get a negative answer. So let's circle that. So if 2 negative numbers give a negative answer, 2 positive numbers give a positive answer. So when we add blank sign numbers, we add the blank blank of each number and blank the sign. So if we go back and look, we've been adding same sign numbers. So this is going to say same sign. We either added 2 positives or 2 negatives. And what ended up happening is we added the absolute value, meaning if I look at this number, it's like adding 1 and 5. The absolute value would be 6. So we're adding the absolute value of each number, and you're also hopefully going to notice that we kept the sign. So 2 negatives or 2 positives, whatever type of numbers we used, we keep the sign. So what I'd like you to try now is the next 3 on your own, and then we will share out at our next lesson. Have a great afternoon, great evening, whenever you're working on this. Take care.